Today in geometry, we're going to look at an Algebra 1 lesson. It's Envision, Chapter 7.1, Adding and Subtracting Polynomials. The Chapter 7 essential question, how do you work with polynomials to rewrite expressions and solve problems? Our essential question for this section, how does adding or subtracting polynomials compare to adding or subtracting integers? After today's lesson, you should be able to combine like terms to simplify polynomials. So let's start out with some vocabulary. First, a monomial is a real number, a variable, or the product of a real number and one or more variables with whole number exponents. The degree of a monomial is the sum of the exponents of the variables of the monomial. A constant has no degree. Any number or variable raised to the power of 0 is always equal to 1. A polynomial is a monomial or the sum or difference of two or more monomials called terms. Polynomials are named according to their degree or their number of terms. The degree of a polynomial is the greatest degree of any term of the polynomial. So first we're going to look at how do we name a polynomial based on their degree. So if it has a degree of 0, its name is a constant. An example of this would be like the number 10. If that is a first degree, this is referred to as a linear because if we graphed it, it would make a line. An example would be like x plus 6. Second degree is referred to as a quadratic, just like our quadratic formula. If we graphed these would be parabolas. So an example, x squared plus 3x minus 12. Degree of third is called a cubic. An example would be like x cubed minus 16. Fourth degree is referred to as a quartic. An example would be like x to the fourth plus x squared minus x minus 3. Fifth degree is called a quintic. An example, x to the fifth minus 21. Sixth degree is just called sixth degree. So anything past 5, we just use the number. So seventh would be 7th degree, 10th degree, 20th degree, things like that. So this would be like x to the 6th plus x to the 4th minus 3x minus 2 as an example. Now let's look at how we would name them based on the number of terms. If it only has one term, that is referred to as a monomial. Example of a monomial, 10xy. It has two terms, it's referred to as a binomial. And so 10x minus 3 is a binomial because I have two different terms. So your terms will be in between either addition or subtraction signs. 3 terms is a trinomial. So an example, x squared plus 3x minus 12. 4 terms, polynomial. So anything with more than 3 terms is just called a polynomial because poly means many. So this could be like x cubed plus 6x squared plus 10x minus 25. So the first thing we're going to practice is the standard form of a polynomial is when the terms are written in descending order of their degree. Okay, so you want the highest degree first, and then they go down in descending order. We're going to name each polynomial by its degree, by the number of terms, and put it in standard form. So this very first one, notice I only have one term because there's no addition or subtraction, so this is a monomial. Since it's a monomial, but I have both an x and a y, if I wanted to name it by its degree, I would add my exponents. So the x has an exponent of 1, the y has an exponent of 2, so 1 plus 2 is 3, so this would be a cubic. and it is already in standard form. Number 2, my highest exponent, again, I would need to add the 3 with the x, the 1 with the y. So this would be a quartic. If I named it by terms, I have 1, 2, 3, so it's a trinomial. And again, it's already in standard form. Number 3, 7 minus 3x to the 4th plus 6x squared. My highest exponent is a 4, so this is a quartic. If I name by terms, again, I have 3 terms, another trinomial. This one I need to put in standard form, so the x to the 4th, that's the highest degree, so negative 3x to the 4th would come first. Then I have x squared, so plus 6x squared, and then plus 7, so that's standard form. Number 4, my highest exponent is 10, so it's a 10th degree. I have 1, 2, 3, 4 terms, so it's referred to as a polynomial. So now in standard form, so negative 18y to the 10th. My next highest exponent is the 5, so minus 5y to the 5th. My next highest exponent is the 3, so plus 16y cubed plus 2y. That's standard form. Number 22, or number 5 is just 22. So this is a 0 degree because we said all constants have a 0 degree. This does not have a variable, so it is a constant. 1 term, so it is a monomial. It's in standard form. All right, so now we're going to look at combining like terms and writing each expression in standard form. So remember that when you're adding and subtracting, you can only add x's with other x's. I can only add x squareds with other x squareds. So I have 4x squared and a negative x squared. So I can combine those. 4x squared minus x squared are going to go together. Plus, and I have a negative 3x plus 3x. So these are what I'm going to combine. So 4x squared minus x squared gets me 3x squared. Negative 3x plus 3x, they go away, so my final answer is just the 3x squared. Number 2, I have a 4x and a 2x. Those are going to get combined. A 3x squared and an x squared are going to get combined, and then this 5 is by itself. I'm going to put it in standard form, so I'm going to do my x squareds first. So 3x squared plus x squared gets me 4x squared. 4x plus 2x gets me plus 6x. I just add or subtract the coefficients out front. And then I just have the plus 5, and that is in standard form. So now to add or subtract polynomials, you simply add or subtract the like terms, combining answers in standard form. So just like what we were doing up there, only now it shows this polynomial plus this one. Again, x squared plus 4x squared gives me 5x squared. This is the only just plain x, so it stays just plus 2x. And then I have 3 plus 5, so plus 8. 4x squared plus 2x minus 3 plus 3x squared plus 6. Again, combine my x squared. So 4 plus 3 gets me 7x squared. Again, that's the only x I have, so plus 2x. Negative 3 plus 6 gives me plus 3. Number 3, now we're going to do subtraction. The trick with subtraction, I need to distribute that negative to everything in those parentheses. So really here I have 3x squared plus 4x plus 2 minus a negative x, which turns to plus x minus 4. This is the only x squared I have, so it stays 3x squared. I have a 4x and an x, so plus 5x. I have a 2 and a negative 4, so minus 2. So again, over here, negative 5x minus 6 minus 4x squared plus 6. So first thing I want to do is distribute this negative to everything in parentheses. So I get minus 4x squared minus 6. X squared is the biggest. It's the only one I have. So negative 4x squared minus 5x. Negative 6 and a negative 6 minus 12. Last thing we're going to look at is applying polynomials. So here it tells me an engineer is reviewing the layout of a solar farm. The solar farm shown has 4 small panels, 33 medium panels, and 32 large panels. What is the total area of the farm's solar panels? So if I want my total area, that's going to be the total of the large plus the total of the medium plus the total of the small. So if we come over here, the large, the total area they tell me is 32x squared plus 384x plus, now let's do the median, 33x squared plus 272x, now plus small, 4x squared plus 24x. So now if I want my total area, I just simply combine like terms. So 32x squared plus 33x squared plus 4x squared gets me 69x squared. 384x plus 272x plus 24x gets me plus 680x. And here, where x is the width in meters. All right, now number 2, what expression models the difference, so difference means subtraction, between the total area of the large solar panels and the total area of the small, okay? So we would take total of the large minus total of small. So the large, we had 32x squared plus 384x minus, in parentheses, the entire small, 4x squared plus 24x. Again, I'm going to distribute my negative. So I get 32x squared plus 384x minus 4x squared minus 24x. So now combine like terms, 32x squared minus 4x squared gives me 28x squared. 384x minus 24x gets me plus 360x. All right, so that's our very first day of an Algebra 1, adding and subtracting polynomials. Tomorrow we'll look at multiplying, and then we'll move on to factoring.